In today's lesson, we're going to continue working with solving equations. Now, due to the complexity of the previous lesson, we're going to break down that objective and focus exclusively on solving equations that require us to apply the distributive property. So in today's objective, students will be able to solve equations for a missing value using the distributive property to combine like terms. So let's go ahead and review how to work with the distributive property and how to combine like terms when we're working with variable expressions. So in this equation, we're looking at the distributive property and we're going to identify that and keep an eye out for terms that are found within parentheses. When you see a term that is within parentheses and a number on the outside, that is going to clue you in that you need to apply the distributive property. And in order to do that, you make sure that the leading factor is multiplied with each of the terms inside the parentheses. So we have a negative 6 times a positive 3x. That gives us a negative 18x. And then we have a negative 6 and a positive 9, which gives us a negative 54. So again, I just want to remind you that if we have terms that are inside the parentheses and a factor on the outside, that means we need to apply the distributive property. Also, I'd like to review what it means to combine like terms when we're working with variables. So you notice that in this number sentence, we have 5x and 8x. And we know that these are like terms because we are working with x's in both of these situations. Now, if this was x squared and this was x, then we're working with not unlike terms, so we wouldn't combine them together. And then we have this constant of negative 7 and this constant of negative 13. And since constants are their own type of terms, we can also combine them together. So a positive 5x and a positive 8x is going to give you a positive 13x. A negative 7 with a negative 13 is going to give you a negative 20. So let's keep in mind on how to combine like terms and apply the distributive property when we're solving equations. So let's take a look at an example problem. So we're solving equations that require the distributive property, and again, I notice and I'm observing there are things inside parentheses and I have a leading factor. That means I have to distribute. So let's distribute the negative 5 to the negative 4x and then distribute the negative 5 to the negative 7. Nothing is happening over here with that 49, so I'm just going to rewrite it. Nothing has happened to that 6x yet, so I'm going to also rewrite that. And then proceed with distributive property. So negative 5 times negative 4x gives me a positive 20x. Negative 5 and negative 7 is going to give me a positive 35. Now once we get to this step, it looks like we now just have to combine like terms. So we did the distributive property, now we combine like terms. 6x plus 20x is going to give us 26x. And then the constants that haven't been touched is now going to just be rewritten. And once we get to this stage of the solving our equation, we just apply OIR. So we apply the operation that is happening to the variable x. We're going to then think about what are the opposite or what's the inverse operations. And then we're going to apply in solving with the reverse order. So in this case, we would be subtracting 35 from both sides. And when we do that, we have an answer of 13 on this side. The positive 35 and the negative 35 cancels out to a 0. And we only have 26x left. Then we close out this problem by dividing both sides by 26. That means my answer is x equals 26 on the numerator and 26 in the denominator means that we can simplify this to 1. 1 times x will just give us x using the identity property. And then 13/26 simplifies to 1/2. Now, I arrived to the operations of minus 35 and divide by 26 because I went through my OIR method. Let's go ahead and try to practice another problem. Look, we have here numbers and terms inside parentheses and a leading factor. That means we need to apply the distributive property. So negative 4k stays the same. Negative 2 times positive 5k gives us a negative 10k. Negative 2 times negative 11 gives us a positive 22. Then we keep 134 the same. Again, we applied the distributive property. Now we combine like terms because we can put the k's together and then deal with the constants later. Negative 4k minus 10k is going to give us negative 14k. Then we add our 22, and that's going to give us 134. Once we get here, this stage, we just solve using OIR. Operation inverse reverse. So let's take a few moments to figure out what k equals by applying OIR. If you solve this problem correctly, you should have arrived with an answer of k equals negative 8. Let's go ahead and try one more practice problem before I let you practice on your own. Again, we have a problem in this situation where we see two variables which keys us to think that we need to probably distribute first and maybe combine like terms. Here's our terms inside the parentheses. Here's our leading factor. Let's go ahead and distribute. 87 stays the same. We have 5m that stays the same. A positive 2 and a positive 2m gives us a positive 4m. A positive 2 and a positive 12 gives us a positive 24. 87 still stays the same. We now combine the like terms. 5m and 4m gives us 9m. And then we still have that 24 as our constant. Once we get to this stage, we're ready because it's a two-step equation. All we have to do is apply OIR. Go ahead and solve for the value of m when you apply the OIR method. Let's take a few moments to figure that out. Great, if you solved this problem correctly, you should have came up with an answer of m equals positive 7. Now it's your turn. You're going to do this problem all on your own, thinking about the two concepts that we have reviewed in this lesson, how to apply the distributive property, and what does it look like when we combine like terms. So in this problem, negative 2h plus 7 times the polynomial inside the parentheses, h minus 3 equals 24. Ask yourself, how are you going to solve using the distributive property? And do we need to combine terms that are alike? Solve for an answer, and when you're finished with this problem, let's challenge yourselves with this problem. Now you'll notice in this particular example, you have your variable comes up 3 times rather than just 2. Remember, same thinking process. Do I need to use the distributive property? And do I need to combine terms that are alike? Good luck. Let's see what you get for the value of s.